So today we're going to continue talking about angles, and today we're going to pair them up and create angle pair relationships. So the first thing you have to understand is that we're talking about relationships and how many people should be in a relationship. Hopefully you're thinking about two, any more than two, and life gets a little bit complicated, right? So we're going to pair them up. We're talking about two angles that form a relationship, and depending on that relationship, we're going to be able to do some things to find angle measures and things like that. Right? So, a reminder, not the first time you've seen complementary or supplementary, but do you remember? Complementary angles are two angles whose sum is 90 degrees. Supplementary angles are two angles whose sum is 180 degrees. One way to remember that is think about alphabetically. C comes before S, right? So complementary comes first. Supplementary comes second, right? Numerically, 90 degrees comes first. 180 comes second. So complementary goes with 90. Supplementary goes with 180. That's a decent way to remember it, right? Now, any two angles anywhere that add up to 90 are going to be complementary, whether they're side by side or far apart from each other or whatever. It doesn't matter. Two angles anywhere are going to be supplementary if they add to 180 degrees. Again, whether they're side by side or they're super far away from each other, right? Now, side by side angles are the next definition for us. Adjacent angles are two angles that share a vertex and a side, right? For example, here's complementary angles, a set that are adjacent and a set that are not, right? So adjacent are these two angles right here, and these two angles definitely share this vertex, and they definitely share this side. So that makes them adjacent, okay? Non-adjacent would just be not sharing a vertex and a side. So these two guys right here, which are interesting enough that they're going to add to 90 degrees, but since they're not adjacent, they don't give us any additional information. The adjacent angles are a bit more interesting because they do give us some additional information, right? If you look at that, here are two angles that add up to 90 degrees, and they're forming this angle, which makes that bigger angle a 90-degree angle, in other words, a right angle. So adjacent complementary angles actually give us more information, and we're going to be able to use that as we turn towards proof writing in our next chapter, okay? Now, same deal with supplementary angles. They don't have to be adjacent. Two angles don't have to be adjacent to be supplementary. They can be these guys right here. But if they are adjacent and supplementary, like these guys here, this angle which is 50, this angle which is 130, they share this vertex and that side, then we get more information. And that is, yes, there are two angles that are side by side that are going to add to 180, but that means that they also form this angle, which is a straight angle. So, again, giving us more information, we can lead to other things later. All right, example here. Can you identify complementary, supplementary, or adjacent angles? Take a look. See if you can come up with the complementary angles, supplementary angles, and adjacent angles. Think about it, try to write them out, and then you can stop the video, try to write them out, and then start it back up and see if you're right. All right, so did you come up with these? Complementary angles, angle BAC and angle RST. Those guys add to 90. Even though they're not next to each other, it's fine. Supplementary angles, angle CAD and angle RST. Again, they're not next to each other, but they add to 180, so they are going to be supplementary. And then adjacent angles, those angles that are sharing a side right here. CAD, BAC, those are your two angles. Adjacent angles. Okay? Hopefully you're able to pick those out. All right. Some additional things that we can do with this. First example here, it says, given the angle 1 is a complement of angle 2. Hearing those words, seeing those words needs to conjure up visions for you, right? Angle 1 and angle 2 are complementary. Of course, if they're side by side, they're going to form a right angle. But right now, all that we can use is the fact that if they're complements, they're going to have to add to 90. So we can write out the measure of angle 1 plus the measure of angle 2 is equal to 90. And then fill in what we know, 68 degrees for angle 1. And go through and solve. Subtract 68 from both sides. And you're going to find out that the measure of angle 2 should be 22 degrees. Okay? Now, that might be a little bit of the long way for some of you guys. You might be able to see right away, just subtract 68 from 90. And if you did, that's great. But sometimes the equation helps too. Kind of the same thing for the next one, knowing that angle 3 and angle 4 are supplements, then all we really know about those guys is that their measures are going to add to 180. Okay? So to find angle 3, we fill in 56 for angle 4, subtract from 180, and find that the measure of angle 3 is going to be 124 degrees. Okay? Piece of cake. Last example here, go ahead and find a complement and a supplement to the angle given, right? A complement and a supplement. Stop the video, see what you can come up with, and start it back up and make sure that you're right. All right. For a complement, just subtract 47 from 90 and get 43 degrees. For a supplement, subtract 47 degrees from 180 and get 133 degrees. Okay? Complements add to 90, supplements add to 180. That's all there is to it. All right. Some more things that we can take a look at. If you're a golf fan, right? When you address the club, when you take the club and you address the ball, you put the club on the ground. The club's going to make a couple supplementary angles with the ground, right? You see it here. One, there. They're supplementary, and when you set these up, they form this straight angle, angle BCD. Right? So, if we have those expressions in there for those angles, we need to find x so that we can find the measure of angle ECD and BCE. Right? So how do we go about setting this up? Well, since they're supplementary, that means they have to do what? Yeah, they have to add to 180. So just take 4x plus 8 plus x plus 2 and set them equal to 180. Right? Piece of cake. 5x here, 10. Subtract 10. Divide by 5. And you get 34. Right? Now, to find the other two angles up here, we're going to take 4 times 34 and add 8 to that. That's going to give you 144. Here, we're going to take 34 plus 2 and get 36. Plug the x in separately and then make sure that your two angles add to 180. And they, in fact, do. Okay? Good. Next example here, it says the angle LMN and angle PRQ are complementary. Go ahead, try to set up an equation, solve for x, and get the two angle measures. Stop the video, you can start it back up and see if you're right. All right, so did you take 4x minus 2 and add to it 9x plus 1 and set it equal to 90 because they're complementary? So we get 13x minus 1 equals 90. We add 1 to both sides, then divide by 13, and x is 7. And if x is 7, then we can come back up here and plug in 7 for x in the first guy and get 26. And then plug in 7 for x for the next guy and get 64. And then we take a look, and those two angles do add to 90. So we are in really good shape. Okay? Check in your work. Make sure you're doing that. All right. Some more relationships. Linear pair and vertical pair. Very different, although they seem to be formed by the same thing, but they're not. Right? So, in your own words, write a definition of a linear pair. Well, it's kind of tough through a video, so let's take a look. Here's a linear pair. These guys are not. So, what are you starting to think about as far as what a linear pair might be? Well, the difference in those two pictures is that a linear pair appeared to need to be adjacent. So we're looking at two adjacent angles, right? And some abbreviations here for you, some symbols. Two adjacent angles. And what are those two adjacent angles doing in that first picture? What word is in linear? Right? And hopefully you're thinking there are two adjacent angles that form a... Yeah, I know a line, but I want to talk about it forming a straight angle. That's where we're going to want to go with this. Because we're talking about two angles, we want to end up, we want to talk about them forming another angle, right? So there are two adjacent angles that form a straight angle. And I know a straight angle looks a whole lot like a line, which is why they're called a linear pair, right? Now, yes, eventually we can talk about a linear pair being supplementary, because if they form a straight angle, then they're going to have to add to 180 just with the angle addition postulate. Okay, but not yet. In the definition, we'll just keep it at them forming a straight angle. Vertical angle is a little bit tougher to come up with, right? Knowing that there are vertical angles in here and not in here. What's the difference in those two pictures? Well, hopefully you're seeing that these are straight lines and these are not, right? So apparently a vertical pair come from two intersecting lines. And they have to be lines, straight lines, right? Now, what you would also need to know up here is that angle 7 and angle 6 are vertical, a vertical pair. Angle 5 and angle 8 are a vertical pair. Remember, pairs 2. So 7 and 6 together form a vertical pair. 5 and 8 together form a vertical pair. There are two sets in there, right? So that being the case, look at them. They're kind of back to back, right? There are two angles that share a vertex. But if you also look again, they do not share a side. If you trace 7 and 6, they do not share a side. Right? So they share a vertex, but not a side. Okay? And they're formed by two intersecting lines. Now, sometimes you can trace the angles, and based on their particular relationship, or based on how you trace them, you might get a letter, right? And that letter might help you remember the relationship as well. For example, if you go back up to the linear pair, if you trace these angles, they kind of make an upside down T, right? So these guys, you're kind of looking for a T, if that makes any sense. And that's going to give you, or an upside down T maybe, and they'll give you a linear pair. If you trace your vertical angles, so 7 and 6, hopefully you're seeing an X there. Right? So look for the X's. And those will lead you to vertical pairs as long as you're looking for the angles that are back to back. All right? So let's try to identify them. Here's a diagram. We need to go through and identify linear pairs and vertical angles. Take a second, see if you can't pick them out, and start the video back up and see if you picked them out correctly. These are the only ones that are in the picture. Okay? For linear pairs, you've got angle 1 and angle 4, which does kind of make a weird looking T. You've got angle 4 and angle 5, which again makes kind of a weird looking T. but they're sharing a side and they're forming a straight line, so those are your linear pairs. Your only set of vertical angles are angle 1 and angle 5, right? Which is, looks like an X, right? But they're formed by, you can just go ahead and make an X and then find the angles that are back-to-back here, right? There are no angles that are back-to-back here. 2 and 4 are not back-to-back because 3 is sitting here, right? So we can't say 2 and 4. All right, hopefully you found those. And also, hopefully it makes sense if you added additional ones, why they're not one of those relationships. If not, come in and we'll talk about it. Okay? All right, a couple more of examples, types of problems that you want to be able to handle. So first example says 2 angles form a linear pair. So right away here in that first sentence, seeing that first sentence, you should start to conjure up images of what that means, right? They're a linear pair. They're going to form a line, so I don't know what those angles look like, but I do know that when you add them, they should add to 180 degrees, right? Because they're going to form a straight angle. If they're a linear pair, they have to form a straight angle. So we're going to add up a couple of angles and set them equal to 180 degrees. The question is, what angles are we going to add together? Well, it says that one angle is 5 times the other one. So let one angle be x, and then the other angle be 5x, and that way one angle will be 5 times as big as the other one. Okay, so that's your equation. 6x equals 180, so then x ends up being 30, and so we've got one angle that's 30 degrees and one angle that's 5 times 30, which is 150 degrees. And those two angles should add to 180, and they do. So we must be on the right track. All right, try the next one, set the equation up, stop the video, and start it back up and see if you're right. Okay, they are complements, so they have to add to 90. And if one angle is twice the measure of the other one, then we're back to setting it up kind of the same way as the previous example, just x plus 2x. Solve this, x ends up being 30. So one angle is 30, the other one is 2 times 30, or 60 degrees, and those two guys do add to 90, so you're in good shape. Okay? That's it. Your homework's sitting out in Canvas. Make sure you have that done by next class.